Welcome to a video on the indefinite integral. So the standard form for integration without our definite values on the integral sign is that, like we learnt with primitives and anti-differentiation, you raise the power and divide by a new power, and then you put the plus c on the end. And if it's inside of brackets with a power, you still raise your power by 1, divide by that new power, but we multiply by the value in front of the x or the differential inside. That also goes on the bottom. So here's some examples. And notice on each of these, there is no definite integrals on the integral sign. So no numbers on the integrals, which means that we always will have a plus c. So for the first one, we're integrating 3x squared plus 5. For the second one, 2x minus 1 to the power of 4. For the third one, 1 over x cubed. And for the fourth one, this is a special case, and we'll have a bit of a look at this when we get to it. So for the first one, it just applies our general rule. So the 3x squared, we raise the power by 1, and we divide by the new power of 3. And 3 over 3 becomes 1. We know that the integral of 5 becomes 5x, and then we do the plus c on the end. Second one, this follows the second rule that we looked at. So you raise the power by 1, which the 4 becomes 5. You divide by the new power, so you put the 5 on the bottom plus the value in front of the x or the differential of what's inside. So that's 5 times 2 on the bottom. Then you add your c, and 5 times 2 on the bottom becomes 10 with the plus c on the end. 1 over x cubed, we can't actually integrate. So we've got no quotient rule, no product rule for this. So we have to treat it a bit differently. So we change 1 over x cubed to x to the minus 3 and then follow the same rules. Raise your power by 1 to minus 2, so just be careful with that. Divide by a new power. And x to the minus 2 is 1 over x squared, and we already have the 2 on the bottom. So we put the minus out the front and we get minus 1 over 2x squared with the plus c after it. Now remember I said that that fourth one was a special case. So if we try to integrate this as is, raise your power by 1 to get 3 and then put that on the bottom and then put the differential on the bottom, we'd end up with an x on the bottom. And you can't have that because when we get to definite integrals, if one of the integral values was a 0, that's impossible to do. So there has to be a different way. And so we expand it using a quadratic expansion. So that becomes x to the 4 minus 10x squared plus 25. And then we use our rule. Raise your power by 1, divide by the new power. And so we get 1/5 x to the 5 minus 10/3 x cubed plus 25x plus that c on the end. Thank you.